This test is not negative. I don't even think I'm putting it. If I do it for next week, it'll be Friday. I think it's the week after next. So we got time, but don't wait till the last minute. Some of y'all gonna wait till the last minute. I already know, but all right. So the title of what we're doing, we've always been. We almost messed that book up. Can you use them pens for that book? All right. So the title for all of this has been simplifying radical expressions. That's all we've been doing since we started this, which was this week. Simplifying radical expressions. Now, specifically, we're going to deal with multiplication. Because I can't say solve. I can only say you can't do them or make it better. You can't solve it. You could make it simpler, but you can't solve it. You can add and subtract, multiply when you can, divide when you can, but you can't solve none of this. Because there's no equal sign. All right? So the first thing I want to, there's a definition I need you to have. So in order to simplify radical expressions, what it is, all right, you need to first know that we have a product rule of radicals. All right, so we have a product rule of radicals, just like we had of exponents. So we have a product rule. And I won't use words for this. I'll talk it out and show what I mean. The product rule of radicals states that whenever you multiply, that's a B right there, make that a B. Whenever you multiply radicals, they are a part of the same radical. So you have these radicands here, these two expressions. Put them under the same one. For instance, the square root of 5 times the square root of 5. Draw you one big long radical and say 5 times 5. Now, your index says you need how many of something to come out? 2. What you have already?
2 5s.
2 5s. So, because we have two of something already, the answer is what? Try it again. I know what you meant. Just 5. All right? We found 2 of something, answer is 5. Let's try it again. Let's say we have the square root of 6 times the square root of 12. Oh, Lord. I don't want to do this one, but I put it on there. Let's do it. All right? So we draw one big long radical with a 6 and a 12 in it, and you factor now. Don't say 6 times 12. Just do it now. Who wants to factor big numbers? 6 and 12 is easy to factor. What's 6? What is 6?
3 times 2.
Yeah, 3 times 2. And 12 is what times what? Series stop. 4 times 3. I'm going to Siri try to give you the answer. 4 times 3. And then 4 is what?
2 times
2 times 2. Now check it out. Every time we find how many of something, what it comes out, right? What do we have 2 of? Man, we got 2 2s here, 2 2s here, and we got 2 3s. So we're pulling out a 2 and a 3. If you pull out a 2 and a 3, what is that? What's that? 2 times 3? What's that? 6. What's left over? Well, remember now, when you break down that 4, you can't use it. So square root of 2. That's it. So don't multiply the numbers. Go ahead and see if you can factor. Let's try it again. Let's try the square root of, let's try 18 and 9. 18 and 9. All right, we're going to put them under the same radical. 18 times 9. And we're going to start breaking this stuff down. What would you give for 18?
9 times 2.
9 times 2. Let's hold right there for a minute. If I say you need 2 or something, under the radical, right? What I have 2 of already? 9. I got 2 9s. Oh, I can stop. I can pull a 9 out and a 2 left over. I can stop right here because it's still under the radical. I don't have to break it down. If it matches, it matches. But let's go ahead and break it down. We're going to do that. 9 is 3 times 3. This 9 is 3 times 3. What do we have 2 of? 3 and 2 what? 2 more 3s, right? What's 3 times 3? We said that a long time ago. So you can factor them down, or when you see it, take it out. And we got a 2 left over. So the answer is 9 square root of 2. All right? So when you are simplifying radical expressions, let me give you some rules for it. All right? In multiplication, we have the product rule. Let me give you some rules. Rule 1. Rule 1 says to multiply the coefficients. Multiply the coefficients. Rule 2 is to use the product rule. Use the product rule for radicals. I use the product rule. Rule 3 is to simplify. Simplify the radicals. And rule 4, which we'll get to next week, is combine the like radicals. All right, we'll say like terms, but same. Now let's do it. Square root of 8. Make sure y'all let me know if y'all can't see now. Square root of 8. There we go. Square root of 8 times negative 3 square root of 2. All right? We're going to follow the rules. First rule says multiply the coefficients. What's the coefficient we have on these 2 radicals? Negative 3 times what? 1. If you don't see a number, there's always understood 1 there. All right? So see what we got. So we're going to say 1 times negative 3. All right? Now, we got to use the product rule for the radicals. You draw one big long radical, and what you going to put underneath?
8 times 2.
8 times 2. All right? Now, we know 3 times. We're going to wait to finish all that on the outside. We may have another number come out. So let's break down the 8. What would you use for 8? What would you use?
4 times 2.
Yeah, I would use 4 times 2. All right? Now, I could circle these 2, but there's a 4 there. I'm just going to keep going because I'm going to keep going. I can circle these 2. Let's go ahead and do it. All right, I see 2 2s. All right, good. And then I'm going to break down this 4 and get 2 times 2. And we got what? 2 more 2s, right? So what's 2 times 2? That's 2 times 2. All right, so we got 4 is going to come out with this stuff here. All right, so on the outside, we got 1 times negative 3 times 4. Nothing left in the radical. 1 times negative 3 is negative 3. Negative 3 times 4 is negative 12. All right, that's it. I did them the same way. I'm doing y'all. All right, here we go. So let's write this one down. Square root of 12 x to the third y times, no coefficient, all right, no coefficient, 6 x to the fifth y to the fourth. All right, so let's go through the rules. It says to multiply the coefficients. Do you have any coefficients? No, I mean it's a 1 times 1, but 1 times 1 is going to stay 1, so we're good. Next thing is we're going to use the product rule. So when we use the product rule, how's this thing going to look? one big radical, 12.6. Put the number side by side. X to the third. We got another X over here. X to the fifth. I'm putting my X's side by side. Y, and then Y to the fourth. I just line my stuff up. I put the two numerical parts together, 12 times 6. I put the two X's together, side to side, and Y to the fourth, side by side. All right? Now, like I said, reduce it now. Don't tell me 6 times 12, then try to reduce it. You can if you want, but I think it's easy to reduce to 12. All right, let's do it. What is 12?
4 times 3.
All right, 4 times 3, 2 times 6. Now, if you use 2 times 6, what do you see under the radical that's alike already?
6.
I can pull it out now and have a 2 left over. But, just in case, let's keep going. 2 times 6, and we got 3 times 2, and that 6 is 2 times 3. What do we have 2 of?
2.
We got 2 2s here, and we got 2 more what?
3.
2 more 3s here. What's 2 times 3?
6.
So a 6 came out like it would at first, and what's left over? You see him?
2.
Yeah, 2 left over. Now, just like we did on Wednesday, because we got variables, don't put the radical right here because you might have to pull out some x's. So we're going to leave some space and put that 2 under the radical. Just leave some space. Just in case we got x's and y's to come out. Now, let's go all the way back to last month. The product rule of exponents states that when you multiply the same base, what you going to do to the exponents? Thank you. I know it's going to come on back. When you multiply the same base, you add the exponents. So that's not x to the third, x to the fifth. That's x to the what?
8.
8. And that's going to be y to the what?
5.
Y to the fifth. Going all the way back. Oh, that's why this test is worth more than other tests, because you have to show me that you learned that stuff. All right? So now, the new stuff is when you have a index, when you have a radical, you have to find out how many times this index goes into those exponents. So in other words, we have x to the 8th, but the index is 2. So divided by 2. So anytime, so we just divide this number by our exponents. How many times 2 going to 8? 4 times, which is 4. Well, how many left over? Nothing. So x to the second is going to come out because we had 2 going to 8. You on your cell phone in here, when you tell me what can I do to get something, I'm going to be on my cell phone. All right? Now, y to the 5th. Same thing. Y to the 5th. All right? And we look at the index. The index is what?
2.
A 2. So, we put the 2 in. How many times 2 going to 5?
It can't.
Yes, it can. 2, 4. You know what I'm saying?
Oh.
Yeah, 2 going to 5. So if I got 5, 2 will go into 5 twice. But that's only 4, so we're going to have some change left over. So for the y, 2 going to 5 twice. So you're going to have a y to the second power. But how many y's left over?
1.
1 y left over. Now, for my people that hate long division, there's still a way you can do this. Okay? If I look at the x to the 8, all right? X to the 8 is how many x's?
8.
All right, 1, 2, 3, 4, 5, 6, 7, 8. Y to the 5th is how many y's? 5, right? 1, 2, 3, 4, 5. Your index say every time you find 2 or something, you pull it out, correct?
Yeah.
All right, look at me, look at this. This should be a 4. I said a 4 right there, and I said 2 going to 8 4 times. Look at me. Fix that on y'all paper, y'all. 4 times, all right? Now, every time I have 2 or something, you circle it. I got 2 x's, that's 1 x. That's another x. That's another x. That's another x. So 4 x's is x to the 4. I got 2 y's here, 2 y's here. That's y to the second. But what's wrong?
Yeah.
1 left over. So if you don't want to do long division, I got you. You just got to find your method you're going to have to do it with. All right? So now, I want you to practice.